We are the automation sensation. For our final project, we adapted the Kuka U-bot to function as a collector bot. Our collector bot can be used either in warehouses or stores to deliver and organize goods. It automates processes found in the retail and shipping industries. This type of robot can operate 24 hours a day, greatly reducing labor costs. With some modifications, it can even be used outdoors or in hazardous environments to keep workers safe. For this demo, the collector bot picks up targets based on color, but it can be easily adapted to collect targets by tags or even textures. This bot can also be expanded to collect minerals and rocks on a space mission once sent to space. One of the most interesting aspects of our collector bot is its ability to perceive its surroundings. It has 2 cameras and 1 proximity sensor. One camera, in the front, is used to search for and navigate towards blocks. The proximity sensor, also in the front, detects the location and the rotation of a block directly in front of the bot. These values are then used for the inverse kinematics, which is used to move the gripper towards a block. The camera on the back of the bot detects if the arm is holding a block. This camera is used as our error detection because the gripper is not 100% successful at picking up the block. The camera is used to check to see if we had an unsuccessful pickup, and if that occurs, we try again. In order to accomplish the task of collecting and delivering targets, the robot repeats the following 5 steps. Step 1. The robot rotates until a target is spotted in the camera feed. If a target isn't found after 2 rotations, the robot powers off to conserve energy. Step 2. Using data calculated from the front camera, the robot navigates to the target in a way such that the target is within reach of the arm. Step 3. Data from the front proximity sensor is used in an inverse kinematics calculation that moves the arm over the target. If the arm cannot reach the target, step 2 is repeated. Step 4. The target is gripped and the arm retracts. The rear camera is then used to detect if the target is in the gripper. If the target is not there, that is to say the gripper failed to grab the target, step 3 is repeated. Step 5. Once the target is firmly grasped, the robot navigates towards its collector bin and drops the target inside. Then, it begins the process all over again. My favorite thing about this project is its build-up. We started from nothing, not even knowing how to use a VREP simulator, and struggling with moving the wheels. Then, one week we got the wheels working, and another week we got the arm moving. Eventually we got forward kinematics, then inverse kinematics, and then we incorporated some decision making. But these were all standalone segments. By the end of it, we were able to put everything together and create a logical system that the robot follows in order to do its decision-making process while also accomplishing a task. And that to me was the impressive part, because we started off with all these little building blocks and we put them together to make something that we can actually do something with.